All right, we're covering 6-3 conditions of parallelograms. Remember to take notes and complete the check it out problems.
We have one learning target today. Prove that a given quadrilateral is a parallelogram. Remember in our last in 6-2 we talked about the properties of a parallelogram, and now we're going to prove that it is.
All right, so these are 3 theorems that are conditions for parallelograms. The first one says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is also a parallelogram. So one pair, these are conditions that are sufficient to determine its parallelogram. One pair of opposite sides are parallel and congruent. And you can see here they have them marked as parallel with the congruence mark. The second theorem says if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. So we don't necessarily know the sides are parallel, but we know that those 2 sides are congruent, these 2 sides are congruent, so we know that it has to be a parallelogram. And the last one on this slide, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Remember, opposite is across from each other, they're not adjacent or next to each other, so B and D are congruent, and A and C, since both opposite pairs of angles are congruent, it has to be a parallelogram.
And here are 2 more theorems. The first one, quadrilateral with angles are supplementary to the consecutive angles. It's a parallelogram. Remember, consecutive angles are supplementary. So those are supplementary and those are supplementary. And the second one, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So BD, diagonal BD is bisected by diagonal AC. These look really similar to what we did in unit 6-2.
Right, these are essentially the converse. So we don't know it's a parallelogram ahead of time, but if we know these particular properties are true, then we can conclude it's a parallelogram. All right, example. We're going to show that JKLM is a parallelogram when A is equal to 3 and B is equal to 9. So we're going to plug 3 in for A. So if we do that here, we're going to get 15 times 3 minus 11, and that's 45 minus 11, which is going to be 34. If we plug it in here, we're going to get... All right, and then I finished off with this one, 10A plus 4. When I plug 3 in for A, I get 34. So that shows me that KJ and LM are congruent. And then when I plug B equals 9 in for this one, I get that side is 51. When I plug it in to this expression, this side is 51. So those 2 sides are congruent. And by our theorem that says we have 2 pairs opposite congruent sides, so it has to be a parallelogram. Parallelogram.
Nice. Okay, so now we want to show that again PQRS is a parallelogram when x equals 10 and y equals 6.5. So here we're talking angles. We're looking for supplementary angles. So plugging in x equals 10 for the sides here, we get 6 times 6.5 plus 7. That angle measures 46 degrees, which is Q. The angle opposite it should be equal if it's a parallelogram, and fortunately we end up with 46 degrees also. And then plugging 10 for x, we get that 134 degrees for r. So on our theorem, look at this, we have consecutive angles are supplementary, and we have 2 pairs. So therefore, we have a parallelogram.
Nice parallelogram.
Thank you.
All right, this is yours. Show that PQRS is a parallelogram when A is 2.4 and B is 9.
So now we're going to apply the conditions. So we want to determine if the quadrilateral must be a parallelogram and justify why if it is. So in this one, this is just like the one we just went through. 107 plus 73, that equals 180. And 107 plus 73 equals 180. So therefore we have consecutive angles are supplementary, and it's a parallelogram. Over here, we have a pair of opposite angles are congruent.
That's all we know, so we don't know if it's a parallelogram.
So this one is yes, and this one is nope, not sure.
All right, it's your turn. You get to determine if you have enough information to determine whether they are parallelograms.
Now we're into a coordinate plane. We want to show that quadrilateral JKLM is a parallelogram by using the definition of parallelograms. Okay, I'm sure you're looking at this going, oh my gosh, coordinate plane. But with this one, we can just, again, I'd sketch out a quadrilateral. And it doesn't matter, you don't have to graph it, but this will give you a nice visual. Label the JKLM. So now this helps you figure out your diagonals. We have JL's diagonal and MK. Remembering one of the conditions we just had where the diagonals bisect each other, that's a parallelogram. So we just have to find the midpoint where these cross because parallelograms have the same midpoint. Diagonals have the same midpoint. So we can find the midpoint of JL and the midpoint of KM. So again, remember to find the midpoint. It's the average of the x-coordinates and the average of the y-coordinates. So midpoint for JL is at the point 3 halves and negative 1/2. The midpoint for KM is also at the point 3 halves and negative 1/2. Therefore, the diagonals have the same midpoint, so it is a parallelogram. And there's another lovely picture.
Nice. All right. Oh, I guess we get to do another one. Do we do another one?
This one's for a different theorem.
Oh, okay. Okay, so we are doing another problem. It's a surprise to me. So we're going to show a different way to determine whether ABCD is a parallelogram. So again, sketch it. And we're not going to necessarily sketch it in the coordinate plane, just so we know which sides are opposite to which. And then we're going to show that we have two opposite pairs of parallel sides. So we're going to use slopes. Remember, if they have lines have the same slopes, they are parallel. So we'll show that AB and DC have the same slope, and AD and BC. I said BC. AB and DC have the same slope, and AD and BC have the same slope. Okay, so I found the slope. Remember, y2 over y1 minus, or divided by x2 minus x1. So here's our slope. It's 1/4. So AB has a slope of 1/4. DC has a slope, sorry, it's a negative 1/4 of a negative 1/4. So these are parallel. When I find the slope of AD, it turns out to be negative 2 over negative 1, which is 2. Slope of BC is also 2, so they're also parallel. And because we have two pairs of parallel sides, we have and these are parallel lines here, so this is a parallelogram.
Nice. So for this one, go ahead and determine if you want to. It says use definition parallelogram, which means taking the slope. The last example we did. You can also use the diagonals to see if they're parallel. So pick whichever method you want to use to show it's a parallelogram.
All right, so conditions for a parallelogram. These are kind of what we went over. First, this is the actual definition. It has to have both pairs. Actually, let me get a different color. Both pairs of opposite sides are parallel. That's the definition. Then we also know it's a parallelogram if one pair of opposite sides is parallel and congruent, or if both pairs of opposite sides are congruent, if both pairs of opposite angles are congruent, and lastly, if one angle is supplementary to both its consecutive angles. Oh, not lastly. Here's lastly, diagonals bisect each other. So any of these things allows you to prove that a figure is a parallelogram. And as it says here, you only have to show that it satisfies one of these conditions. And that's what we did in our examples in the last few slides.
So here's another example. It says the legs of a keyboard tray are connected by a bolt at their midpoints, which allows the tray to be raised or lowered. Why is PQRS always a parallelogram? Well, the key word here is at their midpoints. And the legs are going to be the diagonals. So the diagonals have the same midpoint, therefore it's a parallelogram.
So here is another practical example, a frame attached to a tripod. So look at the information and see how you can use it to ensure the angle of the binoculars stays the same.
So to summarize it, again, make sure you have these conditions, all 6 of them, in your notes. And to be a parallelogram, only one of these conditions have to be met. So sometimes you get to pick how you want to show it's a parallelogram. Bring any questions you have to class, and good luck. Thanks.